Hello, this video is going to talk about comparing numbers in scientific notation. You do not need to write these notes down unless you want to just jot down the two steps, step 1 and step 2 somewhere, but we did not give you a note sheet for this. So to compare numbers in scientific notation, first you'll only have to look at the exponents, just compare the exponents. But if the exponents are the same, you are going to have to look at the coefficients to compare them, the front numbers. We're going to be using the symbols. Remember these little alligators who eat the bigger numbers? So we're going to be using greater than or less than symbols. We'll also be, there might be a chance where the two values are equal. So let's see how these steps work out for us. So first we're going to compare the exponents. So here's two numbers in scientific notation. If we compare the exponents, we can instantly tell which number is bigger. Anything to the 8th power is going to be bigger than anything to the 7th power. If we expanded it, 1, 2, 3, 4, 5, 6, 7, 8. I mean, that would be another way to do it, but it would take us a lot longer. And we can expand this. 1, 2, 3, 4, 5, 6, 7. And I'm going to rewrite that because that looks messy. So there you see 234 million is bigger than 36 million. So it wasn't necessary to expand it, but I just wanted to show you why looking at the exponents is a way to compare the numbers. The bigger the exponent, the bigger the number. So here we go, we're looking at the steps, compare the exponents. Now, in this example, the exponents are the same. Now that doesn't mean that these two numbers are equal. It means if they're the same, we have to look at the coefficients. So now we look and compare 5.3 to 7.19. So in this example, 7.19 is going to be the greater number because that is bigger than 5.3. If we expanded it and wanted to compare it that way, we could. It would take us longer, but I'll show you. So there, I've expanded it, and you can see that 71,900 is bigger than 53,000. Okay, so if the exponents are the same, then move over and take a look at the coefficients. Here's another example that has negative exponents. Let's follow those two steps, compare the exponents. Let's see, those are the same. So now we have to compare the coefficients. So we're comparing 1.5 to 1.05, which is the bigger number. So it looks like a 1.5 would be greater than 1.05. If we expanded it, let's take a look at what that looks like. Okay, so here's what it looks like expanded. And you can see, if we thought about this like money, this is almost a penny and it would round up to 2 cents. And this is a penny and it wouldn't round up. So yes, this is the bigger number, the first one. So it worked. Looking at the coefficients when the exponents are the same is a way to compare these numbers. Okay, now let's go through our steps again. Now here we have negative exponents. We're going to compare the exponent. Now you have to be a little bit careful here when you're thinking about these numbers. Which is bigger, a -4 or a -5? I'm going to say -4 is greater because it's closer to 0 on a number line. So here's a quick number line. Here's -4 and here is -5. Do you see how -4 is closer to 0 on the number line? So -4 is the greater number. So then we don't even have to check the coefficients. If we wanted to look in standard form, let's take a look at what that would look like. So here they are in standard form, and you can see this one has less zeros after the decimal than the second number does. So yes, in fact, this first value is the greater value. Uh-oh, okay, what would we do here? Now we have a number that's in scientific notation, and we have a number that's in standard form. So if we want to compare in scientific notation, we would have to convert first. So the decimal would go after the first non-zero digit, so this would become, the coefficient would be 3.25 times 10, and then we count how many moves. 1, 2, 3, 4, 5 moves, -5 because it's a small number, and we move to the right. All right, now that it's set up, now I can go through the steps. Compare the exponents, and we can see -5 is closer to 0, so -5 is a greater number or a greater exponent than -6. And, oh, it just so happened our coefficients were the same. Okay, here's a similar situation where we have the two numbers, one in standard form and one in scientific notation. So we can convert this. So the decimal is going to go after the first non-zero digit. And then we count from the back to 1, 2, 3, 4. It's going to be 4 moves. It's a +4 because it's a big number. And now we can go through our steps. Compare the exponents, and I can see that 5 is a greater exponent than 4. If you're more comfortable with standard form, so if we want to compare 46,000 and put this into standard form, I mean, that still would be an option for you. It just takes a little bit longer. 1, 2, 3, 4, 5. And then that would be 4, 6 with 4 zeros. Okay, so now you can see it even clearer that 460,000 is greater than 46,000. Finally, you're going to want to practice putting numbers in order from least to greatest, so you can use the same steps, the same strategy. Since I already have 2 that are in scientific notation, I'm just going to put 82,000 into scientific notation. So this would be 8.2 times 10, and then this would be 1, 2, 3, 4. So 10 to the 4th power. And now I would just line them up by order, looking at the exponents. The power of 4 would come first. The power of 6 would come next. And I'm writing these original values back down when I put them in order. And then the power of 7 would come last. Okay, so if you are asked to order them from least to greatest, but they're mixed up, I would convert them all to scientific notation and then order them. Or if you're more comfortable, you could put them all in standard form and then put them in order. Okay, so try this out using the exponents to compare. If the exponents are the same, then you look at the coefficient. Try this out in the practice link on Schoology, which is 2D number 3. Good luck.